Hi, I'm Ryan Miras. I'm an assistant professor at UNCW, and this poster covers rapid response observations that we made along Cape Fear, North Carolina during Hurricane Isaias. Hurricane Isaias struck the U.S. East Coast last year in August of 2020. So it's an interesting fact about the path that Isaias took versus the orientation of our coastline. We have both south and east facing beaches. So based on the orientation and path of Isaias, we had near onshore winds at multiple beaches along our coastline. We made observations of Hurricane Isaias impact up and down the Cape Fear region with nearshore wave buoys, a cross-shore transect of pressure gauges on an uninhabited barrier island, as well as a storm surge observation camera and beach profiling campaign here at Kure Beach. So we talk a little bit about through this poster some of the nearshore wave buoy data observations. One of the key things that we find here is that when looking back at the post-storm hindcast, so the best forecast track, the NHC best track hindcast from the AdCirc storm surge guidance system, that at least for our region in 8-meter water depth, when we compare our measured maximum wave heights versus the modeled maximum wave heights, the model consistently over predicted. However, the timing of the peak wave heights predicted by the model was actually quite well. Then we go and step into some of our campaign carried out at Kure Beach, North Carolina. And what we observed was a pretty significant flattening of the foreshore and significant erosion here with the system, followed by pretty rapid recovery of that beach system. We captured some storm surge observations with our homemade storm surge observation camera, and we go over really unique image processing analysis techniques to enhance and then reduce noise and despeckle images, which are otherwise black and nearly useless to the naked eye, and a full-length time lapse of the video of all of the frames recorded overnight during landfall can be found here at this QR code. Lastly, we talk a little bit about some of the challenges that we faced in trying to sample the cross-shore transformation of wave height over an inundated, uninhabited barrier island. In fact, our pressure sensors also got inundated by sand, as unlike with Kure Beach, just a few miles up beach, up the coast, our pressure sensors experience significant accretion on the order of 10 to 15 centimeters. And with that, what we kind of found was that turns out that the foreshore and backshore steepness and slope, as well as the width of the berm and the height of the berm, as is already sort of known, they played pretty key roles in the morphodynamic response of two different barrier island systems that were right next to each other, which responded completely differently morphodynamically. So hopefully you'll come and stop by the poster virtually or in person. I look forward to seeing you guys there, and I look forward to hanging out in New Orleans. Thanks for listening.